Hello everyone, I hope you all are doing great. So in today's data structure tutorial, we are going to discuss on insertion sort, in which we virtually split the array into the sorted and unsorted part. And the second key point is we take the values from the unsorted part and then place them in the correct position of the sorted part. We place them in the correct position in the sorted part. So let me explain it by an example. Here I have an array of 5 items 10, 9, 100, 29 and 35. So what we are going to do is we will be iterating from array 1 to n. So from first indexing we'll start the iteration and we compare the key element, the current element to the one that precedes it. So I'm going to compare 9 with 10. Then the next step is if my key element is less than the element that precedes it, I'm going to position up this 10 so that I can have the place for 9. So basically to make space for the swapped element, right? So let's do it again. So I'm going to start from 9, indexing 1. So I'm going to check in the first iteration, 9 is less than 10. So I have to make space for the swapped element. So my 10 will be one position up and 9 will come here. Okay, so we are good with the first iteration. 9 and 10, we can see that they are in ascending order. So for second iteration, we have 9, 10, 100, 29 and 35. Fine. So 9 and 10 are already sorted. The rest of the array is unsorted. I'm going to check for 100. Now here I can see there is no element that precedes 100 and is greater than 100, right? So we don't need to perform any swap operation here and the array is sorted till 100. Moving on to the next iteration, 9, 10, 100, 29, 35. So 9, 10, 100 are sorted. Now I'm going to check for 29. Now 100 is greater than 29. So 100 will come one position up and we are going to make space for the swapped element, that is 29. So this is also sorted because 9 and 10, they are less than 29. So we don't need to do the swapping. Moving on to the next iteration, 9, 10, 29, 100 and then it is 35. So till 100 array is sorted and I'm going to compare 35 with the elements that precedes 35 and if they are greater than 35 then we have to do the swap. Now 100 is larger than 35. So 100 will go one position up and we are getting the space for the swapped element. So we can clearly see that now the array is sorted, right? I'm going to do the implementation using C++. So here I have taken an array of 5 size and then I'm going to define the insertion sort function. So for this I'm going to take two variables for the looping. Then I'm going to take one more element which I'll be naming as key. Okay, So we have two loops. Going to put the outer loop. Now, so outer loop starts from the indexing 1. Then it should be less than the size, which is 5. Sorry, here we have n. Then I minus I plus plus. Okay, we are good with the outer loop. And the key element is the current element, which is array at I. Fine. Now the next step, we are going, so with the outer loop, I have taken the unsorted part, and the sorted is the one that precedes the current element. So my j would be I minus 1, and I have to check why j is greater than equal to 0 and every element at j is greater than key. What we have to do? We are going to position up those elements. So that would be array j plus 1 equal to array element at j. Fine. And we would be decrementing j. So it is j minus minus. Okay. So we are good till here. Now, through this operation, we are making the space for the swapped element, that is the key element. So after the inner loop, I'm going to put the key at j plus 1. Fine. So we are done with insertion sort function definition. So I'm going to call the insertion sort function here. Going to pass the parameters, that is name of the array and the size. Now let's print the sorted array. So for int I equal to 0, I less than 5, I plus plus, cout array at I, and the sorted array is, let's run the program. 9, 10, 26, 30, and 100. So I hope you are able to understand the insertion sort. I'm going to provide the GitHub link in the description section so you can access and play around the code. Now moving on to time and the space complexity. So we can clearly see that we are iterating through the array twice. So we have two loops. So my time complexity would result into order of n square. Moving on to the space complexity, it is in place sorting and we are not using extra space to complete our sorting operation. So it will be constant in nature. We are not going beyond the size of the array, right? So it will be order of 1. Hope you like the video. Thank you. Have a good day.